Hello and welcome. In this video tutorial, we're going to be taking a look at the solutions to Unit 7, Lesson 5 homework. Please remember to pause and rewind the video as necessary. Let's begin. In question number 1, it says, in circle O, chord AB and tangent CAD are drawn. It is known that arc AB is 116 degrees. Find each of the following. Well, let's kind of label that on the picture. Arc AB is this one that I'm shading right here in black. And as measured from a central angle, that would be 116 degrees. So go ahead and label that outside the picture. You don't need the central angle on there. I'm just telling you where it came from. What would be the measure of arc BEA? That I'm going to record in blue. Well, BEA would be the major arc that goes all the way around the other end of the circle. Well, if the blue and the black have to add up to 360 degrees, then that must mean the measure of BEA, of arc BEA, has to be 360 minus 116, which would be about 244 degrees. What's the measure of this angle here, CAB, that angle right there? Well, the measure of this angle right here is going to be equal to half of the arc that it intercepts. Well, the arc that this angle intercepts is going to be the black arc right there, AB. So it's going to be half the measure of AB, which we said was 116. So we're going to go half of 116, which is about 58 degrees. Part C, measure angle BAD using two methods. Well, BAD is this larger outside angle here. And we can do that by using tangent chord angle theorem, which states that angle BAD is going to be half of the arc that it intercepts. The arc that intercepts is the big blue arc. So half of BEA, which would be half of 244, which would be 122. Now, using the fact that CAB right here is supplementary to BAD, we can know that angle BAD is just simply 180 degrees minus angle CAB, which was 58 degrees. We saw that above right here. And when we subtract those two, again, we get 122 degrees. So we're consistently getting the same answer to show that the theorem works. In number 2, in the diagram below, secants PT and PU have been drawn from an exterior point P such that 4 arcs have been intercepted with the following ratios. The measure of RS to the measure of ST to the measure of TU to the measure of UR is a 1 to 4 to 4 to 3 ratio, as written right here. If RS equals X, then write the equation that could be used to solve for X and find the value of X. Well, here's the deal. We're going to let the value of Rx, so first of all, let's identify these on the actual picture. RS, I'm going to put in black. RS is this little guy right here. ST is this big one I put in yellow over here. UT is the one I have in blue right here. And then UR is the one I have in gray right here. So there's a total of 4 arcs as we go around the circle. We're going to let, since we're letting RS equal X right here, and you can see that ST and TU are 4 times bigger than that. So that means we're going to let these ones be 4x and 4x, both of them. And then we'll let this one be 3x because it's 3 times bigger than that one. And what we'll do is we're going to set all of these x plus 4x plus 4x plus 3x equal to 360 degrees because that is the full trip around the circle. 360 degrees, all 4 arcs should add up to that. Well, add those up. X plus 4x plus 4x plus 3x adds up to a total of 12x. So we get 12x equals 360. divided by 12, x equals 30. That helps us state the following measurements for these. So this one is 30 degrees. ST would be 4x, TU is 4x, and UR is 3x. So ST would be 4 times 30, or 120. This would also be 120. And this would be 3 times 30, or 90. Find the measure of P. Well, to find the measure of P, it's going to be the bigger arc minus the smaller arc divided by 2. The measure of angle P is going to be big arc minus small arc over 2. The big arc is UT, and that was, or TU, and that was 120 degrees, minus the tiny arc, RS, which was 30 degrees, and then take half of that. Well, we divide those, of course, we get 120 minus 30 is 90, divided by 2 would be 45 degrees. Draw a segment UT. So I'm going to draw a little line segment right there, UT. Estimate what would be the angle of UTS. Well, UTS would be that angle right there. Well, you already know what angle P is. You know what angle P is. Angle P, or actually another way, probably an easier way to look at this would be that this angle right here is an inscribed angle because it touches the circle right there. And it would be half the measure of this arc, this full arc right here, which is the sum of UR and RS. So angle UTS is going to be 1/2 the measure of arc UR plus RS. It's going to be that big arc. That's the sum of those two. So that would be 1/2 times, and then UR was 90 degrees plus RS, which was 30 degrees. And if we add those together, we get 120. Take half of that, we get 60 degrees. In question number 3, circle A shown, secant DE and tangent DG are drawn. It is known that the measure of angle BAC is 72 degrees. Okay, let's figure out what's going on here. BAC, notice that's a central angle. That's 72 degrees. That's central angle 72 degrees. That means that the arc that it intercepts, which is BC, is also 72 degrees. So we'll put a little 72 right there. Now, we need to figure out some other stuff. We just figured out part A. The measure of arc BC is the same as angle BAC, which is 72 degrees. That's easy. But we also need to find other arcs. So what's the measure of arc EBC? Well, what's that? I'm going to put that one in blue. Arc EBC. EBC would be this one in blue all the way across right here. Well, here's kind of the way we can figure it out. Arc EBC, that big arc, big blue arc, is really arc EB plus arc BC. And we were told that EB or BE, whichever you want to call it, is 96. So 96, this was 96 right here, degrees, plus the 72 we just found adds up to a total of 168 degrees. Okay, now find the measure of arc EFC. Well, EFC, this is the gray arc, the rest of the circle. Well, if it's the rest of the circle, then the whole thing has to add up to 360. So what we'll do is to find the measure of arc EFC, we're going to take the whole circle measurement, which is 360, and subtract it from the blue arc EBC. So blue plus gray has to add up to 360. So if I subtract the 168, which was this answer here, then the measure of EFC, arc EFC, not line segment, this is arc. Sorry about that. Is 360 minus 168, or about 192 degrees. Finally, what's the measure of D? Well, the measure of angle D, guys, is going to be the bigger angle. It's going to be E. It's going to be arc EFC minus arc BC. It's the big gray arc. It's this arc right here, the big arc, minus the small arc that intersects between those two lines, the secant line and the tangent line. And then, of course, divided by 2. So this would be 192 minus 72. And then take half of that, we get roughly about 60 degrees. In the diagram in number 4, circle O has 2 tangent lines drawn from an exterior point P to the circle at points A and B. If arc AB, right here, so I'm going to draw in gray, that arc right there is said to be 105, determine the measure of
So angle P would be the big angle, the big arc, 255, not 225, 255 degrees minus the smaller angle, 105 degrees, and then take half, about 75 degrees. And then in part B, you're just repeating this whole thing, but what if the gray arc was a slightly smaller arc at 92 degrees? So the measure of ACB would be larger. If the minor arc is smaller, the major arc will be longer. So 360 minus 92 this time would be 268. Angle P is equal to 268 minus 92 over 2, which is about 88 degrees. Lastly, in part 5, it asks us to determine a relationship to see if there is one between the smaller of the two arcs and the exterior angle. And here's one of the things you should notice. This angle here and this angle here are supplementary. The exterior angle and the smaller arc are supplementary. Now, what does that mean? It means they add up to 180 degrees. So we can see that 105 plus 75 is 180. 92 plus 88 is also 180. But what we want to do is we're going to use the fact that we're going to make the measure of the small arc. We're going to let that be x. We're going to prove this relationship. So to do that, then the blue arc, that means the measure of ACB, the big one, would have to be 360 minus x, right? So angle P would be the big arc, which is 360 minus x, minus the smaller arc, which is x, over 2. Angle P is 360 minus x, which would be minus 2x, over 2. Go ahead and multiply both sides by 2, and we get the fact that 2p would equal 360 minus 2x. Add 2x to both sides, we get 2x plus 2p is equal to 360. Cut everything in half, and look what we have. X, which is the small arc, plus p, always adds up to 180 degrees. I hope you found this video tutorial to be helpful. Again, please rewind and pause as necessary, and thank you.